Good afternoon, everybody. Today we are going to have another webinar by DFG, MPM Infosoft, and FRP regarding data is everything. We all know data plays an important role in Foundry. As Foundry has a lot of variables, the data analysis will help you in getting right actions to reduce your cost and improve your quality. And to talk about it, we have two experts today. One of them is Mr. C. Kleeberg from FRP and Mr. Deepak Choudhary from MPM Infosoft. So I request Mr. C. Kleeberg to start off this webinar.
Yeah,
And audible, sir.
Thank you very much, Sandeep. I'm fully audible, I believe, right?
Yes.
Okay, so let me quickly start sharing the screen so that we can go into the necessary presentation mode. And yeah, okay, here we are. Yeah, Sandeep and everybody, first of all, it's a pleasure and a privilege again to be with you on a webinar hosted by the DFG group. We have done quite a few webinars together in the past year and time. And yeah, we have another digital event, and that's exactly what we want to talk about. We talk about digitalization. And today we want to focus a little bit more about data. And I have published a few papers on this one. Data is everywhere. And my dear friend Deepak Choudhary came up with this fantastic slogan: data is money, lose data, lose money, capture data, capture profit. So let us show you how in Foundry. And that's all what we want to talk today, so that you can really see and embrace how important it is to have a data capturing strategy, number one, and how this can, of course, support you in going towards this typical Foundry 4.0 topic. Today, again, pleasure to be all with you. Thank you, Deepak, for accepting the invitation as well to be with us here today. Happy to have you. And I believe it's going to be a very interesting event that we both share our knowledge, our know-how, as we are both working in the data field for quite some time. Different focus, of course, on either side. You have your part, and I will talk about my parts here today. Yeah. A little bit about the introduction. What we are talking about today is quickly about Foundry 4.0. What is it all about? Communication among systems. How do we start out? What is it? How do we build up a scalable 4.0 data strategy? How do we measure things? Because if we cannot measure it, we cannot control it. We understand big data is equivalent to big money. And from there onwards, we also look into planning and controlling systems, and ultimately, how do we bring this into new concepts versus old school tools. A quick introduction of our company one more time. The RGU in Singapore is a joint venture between RGU Germany and ourselves, and we are active since quite some years already, as you can see. And since October 2019, we are also available directly in India via our company FRP Consulting Private Limited in Vadodara, Gujarat. So that's a very great milestone of ours. We have globally a lot of clients, and they are from the very small ones, less than 20 staff, to very, very large ones, more than 3,000 staff in alu, iron, and steel. And we are proud to say that since January 27, we are really the leading digital platform provider in APAC for metal casting operation. This is on a daily basis seen. Yeah, digitalization, optional or inevitable. Giving here a general talk about this for one slide only. Already back in 2017, 2018, we have been talking about this very, very strongly. And everybody says, yes, we have to do that. So the foundry industry sees this, or was seeing this, a little bit different. And let me emphasize here one more time how important it is that we have to, of course, support the industry in that respect. Where do we come from? First of all, we have the 60s and 70s, labor and skills intensive. Then we have the 80s and 90s before the millennium change, capital and technology intensive. And then we had, of course, the 10s, the zeros, the 10s, and now the 20 digitalization, data intensive age. And we, as a company, being in this field, we can see that very clearly. There is a lot of new emerging technologies coming up, and this is important for the industry. And we see really sustainable growth in areas where, of course, innovation and digitalization prevails in that respect. So we really emphasize you must think and must go into that direction. In Foundry, we published this already a few times in the Foundry magazines in India as well elsewhere. Foundry data is an asset. Data is everywhere. So these areas are already fully explored. And yes, you can read them and you can get inspired and to find out how do we as our company go about this. Well, who would have thought that if we go back 2 or 3 years ago, some big changes are upon us. Just a minute ago, Sandeep and me, we just talked about Zoom. Zoom wasn't known before 2020. 2019, nobody was doing online conferences, but today it's the common thing. So apparently, huge changes are upon us. And yeah, Foundry 4.0, the whole aspect of making a Foundry smart is managing complex changes. So this is exactly what the topic is all about. We want transparency on the shop floor. That means we have planning, and this is demanded by the planning. So if we want to do planning, we require data. We require big data, even in a small company. And how do we get that? How do we get that? Of course, through software systems. And this is also what our company, both companies, is all about. An example I want to show you is here, which I took in a trade show 2 years ago, manufacturing control tower. This is really an understanding. In this case, it was just a building the maintenance of a building, system maintenance, to see how a building can be controlled by various means. Well, how does that apply to Foundry? Actually, quite well, because in a Foundry, when we talk, for example, the melt shop, and I'll come back to that one in a minute's time, we are talking about really understanding the costing of materials, the usage of melt, what parts have I produced in what time, how many charges have I done, and so on and so forth. So data in Foundry is apparently a super important aspect in order to make the company smart. Well, how do we do that, and how do we start? Let me give you some examples. One example is, for example, sensoring. Endless opportunity. A machine, even an old one, you can put a sensor on it. The sensor will give you a digital signal in most cases. You can use that signal. And you can, for example, on, off, has done the job, whatever it may be. Sensoring is no rocket science, it's available. Older machinery can be upgraded. So there's a lot of companies that work with this one already. They sell it as a high tech. It's not really high tech actually, but this is something you should explore, because there is the area where you can capture data, for example, through sensors. One example also from Norican. Norican is the mother company from Deezer, and Deezer itself is also advertising strongly digitalization areas, and they have a lot of sensoring already deployed. They have their own little software system as well that's just applicable for the Deezer foundries, but it's an individual solution by itself. But you can see already the foundries can have technologies. The foundries can capture the data. They are in a position to harvest it, and it's just that they have to do it. If they don't do it, well, then something else can happen. In procurement, it's the same thing. Foundries can go digital in the procurement strategy. We just talked about a second ago about raw material pricing. Yeah, if you know how to handle your procurement strategy better through digital means, well, apparently you can probably control your cost better. You cannot avoid material prices going up, but you can do a better due diligence in understanding how your own costing will be like. Apparently, most foundries don't do that. So there again, it's about understanding the benefits of going digital. Another area where we talk about data is going generally about how do foundries perceive it. We know for many of the companies we have talked to, that they are very strongly influenced by social media. And we also know that in the last 2 years plus alone, we had a huge data explosion globally. Today, more than half of all the commerce transactions are done through mobile. And of course, what's important here to highlight is, however, in many cases, the supply chain is still very, very old school, especially in Foundry as well. So we have to break that up, find ways in order to help them to improve. So what do we do? What are the challenges? First of all, we have to get the mindset right. The mindset means we have to get rid of thinking like it requires big budget, only big companies can afford it. That's not correct. The mindset is we do not have the time and the resources to do that. I would say lame excuse. The mindset is it has to be big equipment, R&D, automation, sophisticated software. Also not really true. The mindset is our company is so small, no need to talk about it. Even the small one, or especially the small ones, are the ones that actually can benefit from it. So the SMEs are the backbone of the industry. That's why we always can tell the SMEs, do something about it. And the mindset is, it will take a long time to affect us, so why bother? Actually, it's affecting everybody already. So now we need to see how do we overcome and how do we can achieve that. First of all, of course, there is difficulty in extract and transfer of data. That's definitely a case. But as I said earlier, sensoring and many other AI solutions already available. Integration of hardware and software between different suppliers. Yeah, different, very important aspect. We need to make sure that you have a consistency here. Rise of cyber threats. Today, espionage and many other threats are not happening in the factory, they're happening in the cyberspace. Be aware of that. So security of your data is important. Lastly, of course, every day new technologies emerge, and we have seen it. As I said just a minute ago, Zoom, 3-4 years unknown. Today, if you don't use it, you cannot even survive. And lack of the knowledge of standards, well, that's something also we need to address, so that everything is standardized over a period of time. Let me give you quickly a rundown on how to do a data strategy at your leisure. First of all, don't jump into buying expensive solutions first, and know your people skills and internal limitations. Know your own SOP level. How many standard operation procedures do you have? Break down your ideas into smaller segments, maybe in a department. Simplify and standardize before digitalization and digitization. So make sure your SOPs are simple enough for everybody to understand, from the shop floor all the way to the top management. And last but not least, start with a pilot run, learn from first successes, and look for good collaboration partners. Do not build a museum, meaning do not build something that nobody will touch. That's important. And with these kind of ideas, you can look into digitalization much faster. So having said that, it's all about how do we build a scalable strategy, and what can we do, what we cannot measure, we cannot control. So we have to measure things. So what do we do? Apparently, as an example, in die casting, also an area of concern, machines can be interactively connected through a terminal. Production data can be visualized in a complete new format. There is almost unlimited availability here. And even the IIF, the Indian Institute of Foundrymen, said smart foundry how? Key elements are, yeah, process automation, most challenging, machine automation, most common, needs process integration, machine learning, very critical for Foundry 4.0, system integration, bringing all digital devices and data on one platform. Ultimately, upskilling human resources is key to success. So here we are very, very much in line with what the IIF also says, that the foundries have to evolutionize. Today, we talk about two major areas. We have on one side the metal side, and we have the other side, the sand side. And I can just frankly say 50% of foundry problems come from metal, and Deepak will highly likely agree with me, 50% of foundry problems come from sand. If you address 100% of these, Doesn't mean you have zero problems, no, but you may have better consistency. And you can see already in this chart how complex it can become when we talk about Foundry data. How complex it can become on getting the Foundry data in the right manner through the right instrument with the right tools into the right platform, because you have to do something with the data, otherwise it's useless. Let me give you an example on what do we mean when we say big data is equivalent to big money. We have in our own software systems one particular software solution called FRP Melt. It's a digital melt shop control management system, way more than just a so-called charge calculation software. And it has already been used in many, many foundries globally, definitely also here in Asia Pacific. Now, let me give you an example here. When we talk about melting, how is an alloy de facto being made? We have charge materials, we have grade specifications, we have melting facilities, we have alloying material, we have charge calculation, we have chemical analysis. In fact, many recipes on how to make an alloy is very often a company secret. So companies treat this quite secretly. But how do they manage the data behind that? That is something in many, many companies, unfortunately, still very, very old school. How do we want to do it? Apparently, we want to understand the making up the how to make up the composition, the batching. How do we do melting and treatment? How do we do the actual pouring and cooling, or how the cooling conditions are, even up to heat treatment in a little. So when we bring this know-how of how to make a melt into a database, apparently we have huge benefits available. Database means we are creating, as an example, a melt report where the composition is being analyzed, where the materials being consumed are being recorded, and even the power consumption per heat, per charge is being. Imagine you have not just one melt report, imagine you have maybe 1,000 melt reports in a month. This can be done very quickly. And this means automatically that you create a database of what you're actually doing. And you can start making data-driven decisions. So we always ask our people, our customers, so why do we should all do this? What's the motivation going into the data field of a melt, which is very, very difficult? Well, apparently the melt shop, in our experience, is the least explored digital area. And that's why we say big data means big money, because what and where can I improve? I need the data for that. How efficient is your process? Again, I need the data. How much do I know about efficiency? What happens if something is unknown on the shop floor? Okay, how much do we? How do we handle a reject charge? What happens if I have to back offs and things like that? Apparently, all these things and many, many more need to be properly documented. Documented, not in such a way, because that's paper. Honestly speaking, hands up, who is still doing something like that? A piece of paper writing down what he or she has done in the melt shop. I tell you, many foundries are still like that. What happens to that piece of paper? Mostly nothing. Nobody takes care of it. So the data in the melt shop is something people just throw away and not treat it as an asset in order to improve cost-wise, profit-wise, and otherwise. Let me give you here one example from our melt software. How many data points can we actually capture? And I just took here alloy and melt materials as an example. We have also melting facilities, spectrometer integration, material management, melting report, post-charge calculation, online info, melt report. So in average, we have about 130 data points. Nobody can handle that if it's just on a piece of paper or in an Excel file. So we have to look into integrated digital means to make sure you benefit from that, and you do not throw away your data. No, you utilize it, of course, on a daily basis. Having done so, of course, huge benefits available. Database means you can calculate faster the end result. You have time savings. You can secure better the melt quality. You have less material consumed. Ensure melt recipe is preserved. Consistency is there. Of course, Time is money in the melt shop. Every minute the furnace is not powered, time and energy saved. So-called what-if scenarios can be done. Material properties can be improved. A lot of transparency and a lot of savings can be achieved. A quick one on the side note: process reliability, planning reliability, cost transparency. All this require, of course, data, as I just said in a minute ago. A small example from Germany. Sorry, I don't have one from India right now, but this is a very interesting example where a foundry was able to reduce power costs down by 21%. And they have that consistently done over the period of time. And this is why we are focusing on melting and making sure that our customers understand you need to capture that data for your own benefits. Last but not least, how do we go to the next step? So when we have captured this data, we have a strategy, we know how to handle it, so sensoring and many, many others. What do we do with it? This picture, as you can see here, is already, let me guess, 15 years old, maybe 20 years old. Look at the monitor, old school monitor. But the worker is reporting directly to a computer, not on a piece of paper, not on a log card, not in an Excel file, straight into the system. Apparently, it's possible. And when we look into, for example, tool management as one example in Foundry, we look into real-time status of a tool, a pattern. Is it available? Is it blocked? Is it available for, is it under repair? Is it due for maintenance? And so on and so forth. How many times have I an imprint? All areas are available. So that's just a pattern management area. Or I look into the idea of tagging my cores with an RFID code, making sure all the core dryness data is captured, the corresponding mold info, so no mismatch of core and mold. All that done to avoid any problems on a later time with the casting itself. Or another example of data collection is in the planning department, knowing upfront, do I have enough capacity? Do I have enough resource loads? Or is my utilization right? So all these things can be done nowadays, all through the correct data capturing in Foundry. Yeah, and ultimately all will end up in dashboards of all typical kinds of visualization of data. I think you all are aware of that, but who has a dashboard at the entrance of the factory showing the company's KPIs on the spot in real time? I haven't seen any Foundry yet, but I hope I will see one very, very soon. Many types of dashboards available, as you can see here, in all kinds of formats, in all kinds of charts, in all kinds of areas with filters and so on. This is the slide I'm very proud of to do, because this is based on Indian data 2 years ago. 2 years ago, we knew that the pig iron price would go up because there was a trend behind that. And we linked the actual data, which we collected from Foundry magazine, and matched it with the Steel Mint website. And we could see very clearly that there is a trend behind that, in this case, pig iron, showing that the price of pig iron is slowly but steadily moving up. And if I can predict that in the future, or I can say if in the next 6 months my material prices go up by a certain percentage, I have to revise my pricing to my customer. Again, this data is invaluable, and I must say it's probably the biggest asset you can have in order to manage your own costing and to stay above the bottom line. So we have challenges, apparently. And the challenges in India, as the way I see it over the years, and many of my friends there have confirmed that, is we have to have, of course, a growth mindset. Everybody has that. We have to have, of course, a fixed mindset. Everybody has that. But what we really need is a digital mindset. The digital mindset allows us to go down that pathway and make sure Foundry data is being collected and we are in a position to utilize it. Why do we need it? Because we have to have a clear transparency. The more we have on transparency, the better it is. We want to know where a part comes from, traceability. We want to know where it is, transparency. We want to know where it goes to, trackability. And ultimately, you want to know precisely, and I repeat the word precisely, how much it costs. That's priceless. So for this and many, many more, you need what we call a digital twin approach. A digital twin is nothing more than using data management. And you mentioned, and I mentioned that before, yeah, look into planning, it requires data. Software supplies data. This is how fast you can go. We are closing the loop now by giving you 3 steps to make sure you embark in your data strategy, that you understand clearly, okay, these are the steps I need to take for my company, and these are the areas I need to look out for in the near future. First of all, I need to look into data collection in an integrated system. Hopefully something like what we have to offer, but not necessarily. I have to make sure everything comes in the right way. I have to make sure I describe the data correctly, and I have to make sure to understand that Excel cannot plan. And I need artificial intelligence through, for example, a digital twin. Another area, I need to invest into HR. Do not forget that. A lot of foundries think I deploy, I don't need to train. No, it's the other way around. I need to train and then I need to deploy. So it's very, very important that, again, intelligent machines, they are a single solution, standalone. They cannot do planning, and then they cannot steer the whole production data. Barcoding, QR coding, laser marking, these are just entries, but it requires the human behind them. So really, really important is, of course, let's do not forget the investment into HR. The biggest question is, of course, how much does it cost to do all that? And our answer is, you have seen already our 10 examples or our 10 steps on how to embark at your leisure. The answer is actually very simple. It's not a question about how much it costs. It's about a question, can I afford not to do it? Foundries that are still not going down the digital pathway and not addressing their biggest asset, their production and manufacturing data, are the foundries which may not survive in the future. We will have to see that. So for us, it's clear, foundries, hopefully everywhere, but especially in India, move away from being the dirty, dangerous, and difficult ones. They go towards the digital, dynamic, and data-driven ones, because they have a lot of treasures on the shop floor. Having said all that, I'd like to close my presentation with quickly giving you our website one more time, frpsolutions.com, r2asia.com, or frpconsulting.in. And Sandeep, with this, I'd like to thank you very much for having me here on board. Foundry industry, go digital. Let's go capture the data. Thank you.
Thank you, sir. Thank you very much for your nice presentation. And really, data collection and analysis is very important. And I remember the paper of what you show the slide of paper of heap of paper, and when you come to our foundry and we have that heap of paper, and after our discussion, we have changed a lot and we transform into digital mode, and I think it has given a lot more confidence, lot more advantages, benefits to us. So I think this is a very right approach to transform from paper to paperless foundry. It will definitely help. It will increase your confidence level. It increase your moral of the employees, and it will help you in many ways, in costing, in quality, in getting good customers everywhere. So thank you very much again for the presentation. And I now request Mr. Deepak Choudhary to start his presentation. Sir, platform is yours now.
Sandeep.
Yes.
And gentlemen from the foundry industry, fellow foundrymen, thank you very much. It's great to be with you here this afternoon. And I appreciate the platform. Thanks to my friend, Mr. Kleeberg, who kept on, pushing me on to share my thoughts on data. And I said, these are all my friends, and it would be a pleasure to do that. It would be a privilege to do that. So here I am, and I'm going to try my best to take forward what Christian has just spoken about in terms of data on the melt shop and how he's pioneering that subject. I am, gentlemen, as you know, mainly concerned with I've always focused on, or not, I'm not concerned with alone. I've been focused on green sand. That's been my life's mission for the last 40 years. That's been my life's passion for the last 40 years. And I hope that till the end of my working life, that will continue to remain so, because I believe focus is everything. I'm going to share with you, because the topic was intriguing in the sense that Christian said that, we are going to talk about data is everywhere. So I have tried to first, now going straight into the subject, that what exactly are we talking about when we talk about data? It's a very misunderstood term. So first, let me tell you what exactly is data, so that we get a perception when we say data. The whole world is saying data. What exactly is data? So, I mean, when you go through life, when you're eating, you're exercising, you're drinking, you're working, you're even going to the doctor, he asks you for your past test results. What is he asking for? He's asking for data, right? Based on that data, he makes a diagnosis and gives you a treatment. So events that impact us even noticeably or imperceptibly each time that there is data being generated. And whether this data is recorded, captured in memory or by a note or an electronic format, or it is forgotten. Let's say that you don't capture the data. That data has not happened. It has happened. The only difference is that someone has taken it and captured it for future use, and someone has just lost it, and it's lost forever. So in machines, for example, when you all have Foundry equipment and they all have PLC systems, you will find that in a period of time, a week, 15 days, 1 month, the data keeps on renewing itself. You don't realize it because you're not capturing it, if you are not capturing it, but your valuable data of the last 1 month is being overwritten by the new data of this month. So all the past data is being lost. And data which is captured in any format is the basis of decision support, in my opinion, for every thought, for every decision, for every action, and for every outcome. In the engineering world, we say that data exists in two formats. One is in the format of experience, so that is limited to the individual human being, and we need to get away from this reliance on individual human beings. I'm not saying this disparagingly, but it's a fact that human beings do not last forever in their jobs or wherever they are. So that intelligence which is gathered over 30 years, 40 years, to appreciate someone then saying that he's got 40 years of experience in doing this, someone might say that Deepak Choudhary has 40 years of green sand systems. The reason why I got into data analytics is because I wanted to perpetuate my experience into something which is more long lasting, which will outlast me, for the benefit of the succeeding generations that will probably read or understand what I've created in terms of data management, data control, data analytics-based decision making. So this now transcends a human being. It becomes the treasure trove for future generations. And reactive decisions lead to less than desirable results. And individual decisions are normally reactive. They are based on preconceived thoughts and notions, and we need to move away from them. So data can be defined by three V's: volume, velocity, and variety. We have got almost all of them in Foundry. So that's massive data that is being generated exceptionally fast, and it is normally incomprehensible because there's so much of data coming in. Velocity means that the sheer speed at which the data is being generated and gathered. And variety are the records and measurements about one or more objects, processes, facts, events, often over a series of time, known as time series data. And this data is available in different forms, from video, text, image, audio, real-time, past, historical, and beyond. And each requires different types of processing and analysis. So in short, data refers to huge volumes of unstructured data that is generated every minute or second of the day. That is the definition of data. So once we know what data is, or we have tried to understand what data is, because it's too short a time to really explain what the entire concept of data is. But let's see what is the importance of data. So I say this with conviction that data is spoken of widely, not only in India, but throughout the world, but it is understood very narrowly. Data is not just a collection of facts and numbers or text images, and it is not just stored in books, computers, or the human brain. It is a mine of information and insight. So as we say, if there is coal under your feet or if there's oil under your feet, what value does it have for you unless you can bring it out of the earth and sell it and bring value to it? So if it is left unmined, it has absolutely no value. So we are Foundrymen on this forum. So we are going to discuss data as numbers and annotations. We will also discuss how we can use data to make our casting processes more reliable. Almost all Foundry equipment these days have digital interfaces, the PLCs. And these PLC interfaces generate data of the process. And as I mentioned to you, if it is not captured, over a few cycles, it is lost. If it is captured, it becomes a repository of the process's performance. It becomes the historical record, the data historical record of your Foundry. Now, let me just show you a typical sand loop in the following slide, and the several data sources which we can tap from this loop. So this gives you an overall picture of what a green sand loop is. Sandeep, can you confirm that everyone is seeing the slide I'm talking about?
Yes, sir.
Okay, great.
It's
So
good. It's good.
yeah, so if you see in this, and I'll just hover my mouse around these blue rectangles. So you have the PLC attached to the dosing station of this coal dust, bentonite, raw sand, water. You have the PLC of the compactability controller. You have PLC of your mixer. You have PLC of your molding machine. And there could be other PLCs, but there could also be a PLC in your laboratory if you have digitalized your laboratory. And there are many other sensor-based PLCs, like the relative humidity and the temperature sensors, etc. So these are the various points from which a Foundry can either generate data and capture it, or are already generating data and can attempt to capture it. And even if you don't do anything with it right now, just bring it into a captured electronic format so that you have something to work on the day you decide to work on it. How we can take this data into the SCADA is a story which I will talk to you about in a case study as we go into the subsequent slides. Now, I want to share with you what normally people who, when they talk about data or data analytics really do not, emphasize. Number one, the question that we need to ask is, do we really have meaningful and authentic data? From my experience in Foundries, even today, meaningful and authentic data is missing. So what we really need is to find ways how we can have it accurate, authenticated, and we have to validate whether that data has been authenticated and is accurate. Now, there is a different degrees of variability in different parameters. So the data capturing frequency, if I say that, okay, I've got this machine, I've got that machine, I've got this 3 machines, and all are generating data. Now and then we have a laboratory, right? So the machine is generating data every 2 minutes. One machine is generating every 1 hour, another machine is generating every 6 hours. And the laboratory is generating once in a day. So we have got to understand what is the frequency of this data capturing, because that determines the variability of the kind of data that you are going to get. And that is important for the next step, that the data that is so captured from varying sources needs to be aligned. So that if you are having a mixer which is generating data every 2 minutes, and you're testing the compactability every 1 hour, then you've got to be able to ensure that your 1 hour compactability test is equal to the closest point at which the last mixer data was generated. Then you have to even calibrate your sensors, etc., very periodically. And you have to also select the right approach for the data gathering facility, data gathering process, SOP. I'm going to share with you what I think all of you know, the name Clayton Christensen, because he's the father of the disruptive innovation theory. And it's a great thing that, this gentleman who talked about management, he spoke about data, which, I found it amazing that how one person can summarize the importance and the relevance of data so well. I'm going to read it for you. Data is not a phenomenon. It is a representation of the phenomena. So the data you gather is about the sand system, about the sand properties. It's not about the sand system. And we must also realize that God, or inverted commas, sand system, did not create the data. Any piece of data that you or I has ever encountered was created by a human being. We set the logics, we set the PLCs, we program the PLCs. And since we are unable to fully capture this complex world, we as human beings use our bounded rationality, fixed rationality, to make decisions about what aspects of the phenomena to include and what to exclude. So data is also subject to personal bias. What should I take as data and what I will not take as data, or what I will ignore as data? So by definition, these decisions reflect our pre-existing ways of thinking about our systems and processes. I'm just changing his words a little to make it more relevant to our discussion. And these ways of thinking are sometimes good and reliable because we know the causal relationships like active play and WTS, but oftentimes they are not. So no quantity, no velocity or granularity of data can solve this fundamental problem. He goes ahead to say in his theory that you have to get into the system. You have to infuse your data with domain understanding, which comes from research, that gives you ultimately the solution. Therefore, I say that data without insight is meaningless data, and data without actionable insight is just passive data. So this is what I would say a perfect example of meaningless data. So you've got varying total surface area of the sand, you've got a varying product mix of your castings, you've got a returns, you don't have return sand management, or you do have it. So you know the arbitrage gap between prepared sand and return sand. We do not know the number of lags, how fast your loop is moving, sand loop is moving. Sometimes it is moving once in a day, sometimes it is moving 2 times in a day, sometimes it is moving once in 2 days, depending on production runs. That impacts our data, quality of our data. Then you have varying core sand going into the sand mix. Now that can go from 3% to 12% in block and head foundries, for example. I mean, that's a huge variation. So you have multivariate cause and effect relationships. And if you see, I'll just take you through the next slide. I'll just show you what I mean. But if we look at the data quality distribution, it means that, what is your clean data and what is orphan data or mismatched data. So clean data from the point of view that we created Sandman is a very simple equation. Date and time of metal poured should be equal to the date and time of the sand prepared, should be equal to the date and time of the rejection resulting from that. And the consumption of additive should also be equal to the date and time of all these three put together. When you have that perfect alignment, you have some meaningful data. You have some valid data. This is an example only. There's a full matrix there, but I just wanted to give you a snapshot that out of the 20 tests that we do, if you change the temper water of the sand, it immediately impacts about 6 properties of the sand. Active clay, if you change it, it changes again 7 or 8 properties of the sand. That shows that every property is multivariably interrelated to the other properties that are being tested. So you have got a really complex cause and effect interrelationship, which is not possible to control on a symptomatic linear cause and effect relationship basis. So when I said that actionable insight is very crucial, I'm just giving you an example that when we do even simple analytics of what I'm just trying to present to you, what we developed in the Sandman DigiSmart model, which is a smaller model of the digital wallet of a foundry, and how it can give you simple insights. So foundries which do not want very complex analytics, but would like to have simple analytics, says, okay, what is my correlation between the rejections and the parameters? So you have rejections here in all these columns, and you have the sand parameters on the left-hand side. And I just take an example of a negative correlation of compactability. What does it mean? That as compactability is increased, sand fusion will reduce. Similarly, it says that moisture has a direct correlation with the rejection. So you reduce moisture, rejections will reduce. The other here is data correlation between prepared sand versus consumption. Here also, I'm sorry, what do you call, the font is very small here because we pulled it out of the program. So a positive correlation I've already mentioned to you. And the example here is decrease in compactability percentage. So if you see, the compactability has a positive correlation because it's in green. Decrease in compactability percentage will decrease moisture, and increase in permeability number will decrease the addition of flustron or coal dust. This is the kind of actionable insight that you can get. So if you want to reduce your, you want to reduce your rejections, or you want to control your consumption versus your prepared sand properties, you are able to take actionable insights. You can decide how much to increase and how much to reduce. Sandman DigiSmart gives you that capabilities. It also gives you complete, precise support on how much to increase and how much to reduce. But even if it doesn't, just the directional support itself should be able to give the way forward. And that is what I mean by saying that any data which does not give the way forward is fundamentally passive data. It's just data, and from paper, you have changed it to electronic format, but that's it, it's done. So let's take the next step, that what do I need to do integrated digitalization of data, as Christian also explained in a part of his presentation. And here I'm focusing on higher integrity modes and more precise casting outcomes. So as Christian also said, we need smart sensors to be able to collect data. We need Internet of Things. We need to be able to exchange information between the molding line, mixer, compactability controller, etc. We need cloud computing for analytics. And we need data analytics, which is actually the algorithms which actually process the interrelationships and give you outputs to give you better casting outcomes based on clusters and regression techniques. So instead of just talking about what I just said, I'm going to show you a case study that how can you move towards true IIoT in your foundry. Each one of you who is here on this webinar, gentlemen, I can tell you that it is easy and it is not expensive. And it is not only for the big guys. Anybody can do this. And a very simple thing. I'm not talking about, the digital wallet or any such thing right now. Simple thing. Compactability is one of the most important controlling factors in a foundry green sand system. We all acknowledge that because it is directly related to moisture. Now, if you see in your foundry, the variation of the lab compactability in the absence of decision support is plus or minus 5, because most of the times foundrymen do not change the compactability set point in order to achieve the lab compactability, the target lab compactability. If it was a data analytics based output, if the variable output was the lab compactability, the variable input would have been the variation in the compactability set point at the compactability controller. What we really need to do to get in modes of high integrity, good compaction, which will ultimately give you less expansion defects, less fusion defects also, is basically to ensure that the compactability to moisture ratio is maintained with integrity, and that the mold is compact enough to handle the metallostatic pressure of the metal being poured into it. And we therefore need to ensure that we factor in what is the ambient humidity, what is the ambient temperature, what are the additives variably being added into the system, what is the return sand moisture and return sand temperature. That's very important. And we also know the lab compactability target. By just taking into account these 4 or 5 fundamental or very basic data points, which can be individually sensed by sensors, not expensive sensors. I'll even put a figure to it. At around 3 lakhs rupees, you can have a complete sensor-based compactability control system. And what does it do for you? It brings the variance in the lab compactability, target lab compactability to ±2. So if you have set a target of 40 as the lab compactability, you will achieve 90% of the time by this analytics that we can provide the variation between ±2, that is between 38 to 42. If you see it today and you recognize it, and I'm not saying it for everybody, but I'm telling you, most foundrymen agree that their variations can be in the range of ±5. If we are able to reduce that ±5 to ±2, because now we have database decision support based on the sensors, we are in a very good place. This is what we do. This is a patented algorithm by MPM Infosoft. It is known as VComp SP. So we take Foundry data from the compactability controller, set point, discharge compactability. We take prepared sand data, lab compactability, sensor data of humidity, ambient temperature, return sand moisture, return sand temperature. This analytics you may or you may not want, it's up to you, but we can use this data, align the data, put it into a predictive and optimized algorithm, and we can predict the compactability set point, which will be variable. Now, I'm not trying to, sell the product. I'm just trying to sell the idea that if we want to have molds, if we want to have green sand molds of very good integrity in order to prevent expansion defects, in order to maintain the integrity of the casting dimensions and avoid wastage of our metal and prevent, fusion issues, prevent the lack of control on moisture, we can tap into this data source and do what we need to do. For example, if you see this chart in front of you, that this is a compactability set point which is consistent over 15,000 data points at 46. So somebody in the Foundry has not changed the compactability set point over a period of time. 15,000 points, it was the same. Now with variable compactability set point, you can see that the compactability set point is all over the place because it is variable. And what happens when you have a variable set point? This is what happens. This is when Sandman was in place also. And this is when the VComp SP was put in place. And you can see the reduction in the rejections. So even though I have more time, I just fundamentally wanted to share with you the fundamentals of what data is and how every foundry can climb onto the IITO platform, the industrial Internet of Things. It's not expensive. I just mentioned to you, the equipment is not expensive at all. It's just the mindset that we need to get there, and that we should get there, and that we should do this, that we should take that decision that is missing in foundries which are in my brotherhood today. And that is why I want to share my views with you as passionately as I can. And here I want to conclude by sharing a short story how data analysis shortened global sea routes in the mid 1800s, when there was no computers, no Wi-Fi, no GPS. I want you to meet late Lieutenant Matthew Maury of the US Navy in 1826. In October 1939, Lieutenant Maury was a bright naval officer of the US Navy, and because of an accident, he sustained severe leg injuries, which put an end to his naval career. In 42, at the age of 36, he was put into a place designated as officer in charge of depots of charts and instruments. Let me tell you, even in those days, that was a very unsexy job. Realizing that, now this is his words, that data is the tedious future is sure to supply me. He forecast that data is going to keep on increasing in the future. Way back in 1942, he started examining old logbooks and discovered that they contained useful information for plotting winds and currents encountered by ocean navigators. By 1947, he was able to publish his first wind and current chart of the North Atlantic. By 1851, he shared these charts with all the captains of almost 1,000 vessels in all the oceans. They were sending him reports by filling in the charts that he had constructed for them. And they were able to track trade winds, pilot charts, thermal charts, whale charts, in addition to the wind and current charts. And what happened? The average passage from New York to San Francisco, which required 188 days, gentlemen, was completed in 89 days, 21 hours. That's more than a 50% reduction. The voyage to Australia, which required 120 days each way, was reduced by 1/3, and that to the equator by 10 days. This saving in sailing time, it takes no genius to guess that, meant many millions annually in ocean commerce were saved. And it won the praise of the world. He was, christened as benefactor of mankind, especially from mariners, who wrote, one of them wrote to him that until I took up your work, I had been traversing the ocean blindfolded. And I remember a very intelligent and forward-looking, European foundryman, when he came to our stand in one of the IFEX, and his people were talking about analytics and how difficult, and he said, guys, we are flying blind. If we adopt analytics, at least we will have one eye open. So I want to leave this talk to you with this statement, that in this day and age of big data and cloud computing power, foundries are still thinking that data is only digitalization. Digitalization is only the first step to Industry 4.0. It is not Industry 4.0. The most important step is to engage with analytics for actionable insights. You can cut rejections by half and more. You can optimize your consumption. Increased consumption is a waste. It is possible. And we just have to be open to technology and take leadership in application of analytics. So we can talk a lot on webinars and we can do, a lot of discussions. But ultimately, if I was to say, raise your hands, as Christian Kleeberg said in a different context, how many people who are here on the webinar and how many people do you know are really applying analytics in their foundries? I would say it is next to zero. So give data a chance to help you capture lost profits. That is the way to go forward. The cost of the application will be paid back, and I'm saying this with a lot of confidence, first 6 months of your investment. So thank you very much, Sandeep. Thank you very much, gentlemen. I want to thank Dynamic Foundry Group. I want to thank Christian Kleeberg of FRP, Foundry men and women present all over the world and India for the opportunity to address and present at the Data is Everywhere webinar today. Thank you. Guys, I'm done.
Sandeep?
Sandeep, are you awake?
Is he still with us?
I don't know.
I think he bailed out.
Don't tell me I have to start all over again.
That's funny. That's funny. That's funny. No. That's funny. I cannot see him. I cannot see him. Okay. Probably we have to close the session without. Thank you very much, Deepak. That was absolutely enlightening. I loved it.
Thank you.
And
Thank you very much.
Everybody enjoyed it. We have a video on this one, so I will stop the recording now on behalf of